So we are going to solve this rational equation that we have here in three ways. We're going to solve it. First, we're going to solve it algebraically. Then we're going to use a graph and a table on the calculator to solve it, just so you can see all three ways that we can solve this problem. So the initial equation is this. And to solve this algebraically, over here, put this over 1 so that you can have a proportion and cross multiply to solve it. So cross multiplying that, we will get 0.360 times 60 plus x. And on the right side, we'll get 1 times 12 plus x. So distributing on the left, we get 21.6 plus 0.360x. On the right side, distributing 1 doesn't change anything. So this is what we're solving. So to solve this, I'm going to subtract this to get my x's together. And that on the right side will give me 12 plus 0.64x. And on the left side, 21.6. Then I'll subtract 12 to get my constants on the same side. That'll give me 9.6, 0.64x. And then divide by 0.64. And that gives me x equals 15. So what that tells me is that in this equation, x is 15, meaning that he needs to get 15 more hits in a row at his next 15 at-bats to have a batting average of .360. So consecutive hits, 15 consecutive hits would be the answer to that question. Now, I also want to show you guys how to solve that graphically with the calculator and using a table with the calculator. So I'm going to get my calculator on the screen here. So in my calculator, I open a graph and I plot each side of the equation. So I'm going to start with the right side. And with my Inspire calculator, I like that it has, control divide, and we can do our fraction template here. 12 plus x is the numerator, and then 60 plus x is the denominator. And we graph that. And then I'm going to push tab, and I'm going to graph the other side, which is .360. And this is what I'm looking at. This is a standard window, and so you can see we're looking for when they cross, and it's really kind of hard to tell looking at it right now the way that it is. So I'm going to do a little bit of zooming on this window so we can see it better. So I'm going to go to Menu, Window, Zoom, and I'm going to zoom in. I think that they're crossing kind of over here. So I'm going to zoom in over here and just see if I can see where they're crossing. Okay, and they might be crossing here. I'm not sure. If you want to see, you can zoom in again if you wanted to. So I'm going to zoom in again kind of over here. It looks like they're sort of crossing there. And if you want to see if you can see it crossing, you can go to Analyze an Intersection and then start when it's not crossing and click and then highlight. And you can see that it didn't pick up any points, so it's not finding an intersection yet. So what I'm going to have to do is I'm going to have to zoom out a little bit here. So I'm going to zoom out. I'm going to zoom out over here. Okay, and let's do analyzing the intersection again. And let's see, can we find it? Oh, there it is. So it got the intersection at 15.36. Remember, 0.36 is the y value there. That's what it was supposed to be equal to. That's happening when x is 15. So that's the way to do that using a graph on the calculator. It's kind of, you have to mess with your window a lot and zooming, but you can find it. And then the other thing to do is to push Control T for the third method, which is using a table. And they want to know when this first equation, which is right here in brown on my table, when is that equal to 0.36? Using a table only works if it's like a really, really perfect value. So you can try and see. So I'm just scrolling down my table looking for 0.36 in the y value. Oh, there it is, right there. You can see it lines up when x is 15, y is 0.36. So you can find the intersection with the table that way as well. So those are the three methods that we have for solving that. So I'm just going to move this onto that screen with the other one. So we did algebraically at the top, and then we had graphically, and then we had on our table how to find that in all three ways.